Okay. All right, so we're starting a brand new unit on conics. You have actually dealt with some conics before. You probably didn't call them conics. But just looking at this formula sheet that I gave you, have you graphed any of these things before? Which ones? Huh? And circles and parabolas. So you probably didn't call them conics at the time. Maybe you did. But you have graphed these before. You graphed these in geometry, maybe even some in algebra too. And then you've graphed parabolas. Maybe not the sideways parabolas. We'll graph those. But you've definitely graphed the up and downward facing parabolas before. Okay, so the two new ones that we'll eventually get to are ellipse and hyperbolas. Fancy name. And the reason these are called conics is because if you take a cone, so the root word of conics is cone, if you take a cone and slice it in certain ways, then the cross section of that slice are these four different shapes. So if we took a cone and we sliced it parallel to the base, then that little slice that we got would just be a circle. The closer to the top of the cone, the smaller the circle would be, and the closer to the bottom of the base, the bigger the circle would be. If we sliced this cone at a diagonal, not parallel to the base, but at a slant, then that cross section would not be circular, it would be elliptical, an ellipse. Sometimes we'll call it an oval. Okay? Then if we slice this not perpendicular to the base, then what we get is that shape right there that we call a parabola. And if we did the slicing up here, then we would get an upward facing parabola. And then to get a hyperbola, you need both cones that are like the tips of the cones are touching. And if you drop this down perpendicular, you actually get two pieces that are shaved off. One looks like a parabola up here, and one looks like a parabola down here. But together, both of those are called a hyperbola. And you'll notice on the hyperbola formulas, there are two pieces to those curves, here or here. Okay? All right, so this one is probably the most involved, I would say, followed probably by the parabola, then the ellipse, and the easiest of these is a circle. I mean, you could tell just by looking at the formula sheet, there's not much listed there, is there? So that's the one that we're going to start with today. We're going to tackle the easy one first. And probably the majority of this will be a review, so hopefully it'll come back pretty easily to you. Okay, so let's take a look at this circle here. It is centered at the origin, and I've got some generic ordered pair XY on the circle, and then I drew out from the origin to this ordered pair, which is really just a radius of that circle. And then this is X, this is Y, and you're thinking, okay, she said we weren't doing sine, cosine, tangent. We're not. But if we just use this right triangle and set up Pythagorean theorem, we have x squared plus y squared equals r squared. And that is the standard form of an equation of a circle that is centered at the origin. So if we have a nice simple little circle centered at 0, 0, then that is how we would write the equation of the circle. Now, we'd have to figure out what the radius is and plop that number in for r, but that would be our equation. And you should have done that in geometry already. Okay, but not all circles are centered at the origin. Most are not, right? So how would we write the equation of a circle when it's not centered at the origin? Okay, so the generic circle that I have here has a center point h, k. And those are just the coordinates that we generically use for the center of a circle when it's not 0, 0. I have a generic ordered pair xy that's on the circle. And if I connect the center to a point on the circle, then that's the radius, right? Okay, so I'm going to still form a right triangle. But my right triangle is going to be like stuck in that circle somewhere. Okay, so I'm going to label a few things. If this x coordinate is x, then I'm going to mark on the x-axis x. And this y coordinate is y. So that if I go over x, up y, I'm at the ordered pair xy. Okay, I'm going to label this as H. Because if my center is labeled HK, then I had to go over H to get to that point. And I had to go up K. So K is over here. So to get to the center, I went over H, up K, plotted the point. Okay, so normally we'd be using numbers like this is 2, and this is 8, this is 3, and this is 5, etc. But I'm just using generic values here. Okay, so on my triangle, what is the length of this side? Okay, and think about it this way first. What if this was 2 and this was 8? Then how long would that be? 6. So what did you do to get it? Okay, so if this is H and this is X, how long is that side? What? X minus H, the bigger one minus the smaller one. Just like you said, 8 minus 2 would have to be 6. So this side right here has to be X minus H. Okay, how tall is this side over here? Well, think about this. If this was 3 and this was 5, then that would be a distance of 2. Because we would take 5 and subtract 3. Isn't that what I said? I forget what I said now. We would take the bigger minus the smaller. So how tall is this side of the triangle? Bigger minus smaller would be Y minus K. All right, so that's kind of busy. So I'm going to come over here, and I'm going to just redraw what we talked about. So I have a right triangle, and the hypotenuse is whatever the radius of the circle is. This length over here is X minus H, and this length here is Y minus K. So it's a right triangle. I can use the Pythagorean theorem. So I'm going to say the bottom leg there squared plus the vertical leg over there squared, so that's your A squared plus B squared, equals the hypotenuse squared. And that is the standard form of a circle not centered at the origin. We could also use it for the origin. H and K would just be 0. So this is our formula for a circle. Now this is the standard form of a circle. And so if I see where I got all those crazy letters. Okay, does that ring a bell from geometry? A little bit? Not at all. Teensy bit, maybe. Okay, next page, I've got the equation written out for you here. Standard form of the equation of a circle, exactly what we came up with, where HK is the center and R is the radius. Okay, so I'm giving you, on these next two, I'm giving you an equation, and we are going to identify the center and the radius and then graph them. Okay, so remember this is X minus H, Y minus K equals R squared. Okay, so if there is a minus 1 here, what is H? And notice in the formula it's minus H. So what was I subtracting there? Max, use 1. So the H is 1. That means that my center point has an X coordinate of 1. Because the center is HK. Alright, what is being subtracted here? A 2. So the Y coordinate of my center point is 2. Okay, now be careful. 64 is not the radius. That is the radius squared. So the radius will be the square root of 64. So the radius is 8. Is everybody okay with that? Alright, so to plot it, let's plot the center point first. Find your center of 1, 2. Now, it's kind of funny because the center is not on the circle, is it? But the center is key to forming the circle, even though it's not on it. And that's true with all of these conic sections. Okay, so if I told you that the radius was 8, the easiest way I think to graph them is to go from the center north, south, east, west, 8 units, and then connect them. And try not to make a diamond. That's the tricky part. Okay, so count 8 in all 4 directions. Okay, so all 4 of those points that we plotted are on the circle. And now the tricky part is connecting them in a circular manner. And it's very hard to do it well. I usually end up being a little lopsided. Sometimes like diamonds or potatoes, or try to make it as circular as you can. Yours does or mine does? Yours. Who has a really bad one? Anybody?
Mine's beautiful.
Yours is beautiful? Yeah, it's pretty good. Rhett is working on his. He's being meticulous up here. All right, so that's it. That's pretty easy, isn't it? All right, so let's look at the next one. What is my h value? What is being subtracted from x? Nothing. So that means that the center point has an x coordinate of 0. What's being subtracted here? -5, because it became +5. So remember, the formula is set up as minus something. But if there's a plus, that means I subtracted a negative. So the y coordinate is -5. So kind of the easy thing to remember in your head is you're going to take the opposite of that number. Like if I look at this as being a -1, then +1 is my coordinate. If this is a plus, then my coordinate was really negative. Okay, what's the radius of this one? 3. Take the square root of 9, and we get a radius of 3. The smaller they are, the easier they are to draw well. Okay, so we'll plot our center point, 0, -5. And we're going to go all 4 directions, 3 units. And connect. And there's our circle. Question? All right, we're going to do the opposite next. I'm giving you the center. I'm giving you the radius. We're going to write the equation of the circle. Okay, so we have to remember that this is what in our formula? The -2 is h, and this -7 is, can I have a k? Okay? Okay, thank you. And that is r. That is not r squared. That is r. Okay, so let's go back to our formula. And it says to write x minus h. But if I subtract a -2, it will become +2 squared. Plus y minus k, but if k is a -7, that will become plus, equals 16 squared. Now, we can leave it that way if you want, or we can go ahead and just square 16. I'm going to leave it both ways. I would probably go ahead and square it. And who's got a calculator handy? What is it? Or do you know what 16 squared is? 256. Easy enough? All right, let's drop down to B, below this one. Okay, so I'm giving you H, I'm giving you K, I'm not giving you R. I'm giving you the diameter. So if you're given the diameter, how do you find the radius? Divide it by 2. Okay, so let's figure out what the radius is first. Diameter divided by 2, square root of 30 divided by 2. Can I simplify that? Like 30 is not a perfect square. 30 doesn't have a factor that's a perfect square. So I'm just going to leave it like that. It'll be easier to square if I leave it like that. Okay, so let's start with our equation. X minus -2 becomes plus 2 squared, plus y minus k, so y minus 6 squared, equals square root of 30 over 2 squared. And don't grab that calculator yet. What happens when I square the square root of 30? It's just 30. Yeah, the square and the square root cancel each other out. And then what is 2 squared? 4. So that's just going to be 30 over 4, and then we'll reduce that. Or you can go ahead and reduce it now if you want to. I'm going to put this middle step in here of 30 over 4. Okay, 30 over 4 is what? 15 over 2, or you can leave it 7.5, whatever floats your boat. Okay, question on that. All right, let's jump back up to C. Okay, so I gave you the center point, but I gave you the circumference of the circle. Okay, dig in that brain. What is the formula for circumference of a circle? 2 pi r. Nice. Sometimes people say pi times diameter because 2 times radius is diameter. I personally like 2 pi r. Okay, so I'm giving you the circumference so that you can find the radius. Okay, so circumference is 10 pi. So 10 pi, putting that in the place of C, equals 2 pi r. Well, if I want to solve that for r, I'm going to divide both sides by 2 pi. 2 and pi cancel. Pi cancels, and 10 divided by 2 is 5. So we took the circumference, found the radius, now we can write our equation. So I have x minus h, but minus a negative becomes plus 8, plus, okay, y minus 0 squared equals 5 squared. Now, if you want to leave it at y minus 0, that is perfectly fine, but how else could we write that? Just y squared. So if you want to keep the 0, just to remind you that that coordinate is 0, that's perfectly fine. But I'm going to just leave it y squared. Question on that? Okay, the last one here, I'm giving you the center, and I'm giving you the area of the circle. We have to find the radius. All right, dig back in that brain. What is the formula for area of a circle? Charles, you got us again? No? He's going to pass it off to someone else. Lanier? Area of a circle. Somebody knows it. Oh, y'all, I'm gonna go back and change those Q1 grades right now. Yes, pi r squared. Pi r squared is area, 2 pi r is circumference. Okay, so I'm giving you area is 10 pi square root 2, and that equals pi r squared. Okay, how about if we divide by the pi's and get rid of those? Those are just numbers. So now I have 10 square root 2 equals r squared. How do I find r? If I know r squared, but I need r, I need to do what? Square root. I think we're going to go with a decimal on this one because I don't really want to leave it the square root of 10 square root of 2. Now, normally I would tell you when you take the square root of 2 sides of an equation, don't forget plus or minus, but this is a radius of a circle, and it won't be negative, right? That's a distance, so that will always be positive. And let's see, crunch that through your calculator. If you need a calculator, go ahead and grab it. And let's see what our square root of 10 square root of 2 equals 3.76. Okay, so all that to find our radius. Now we can write our equation. Not left very much room for myself here. There we go. All right, x minus -5 becomes plus 5 squared, plus y minus 6 squared equals 3.76 squared. Now, I can square that number, and I'll leave it a decimal. Question? Absolutely. You look a little pale. Need somebody to go with you? Okay. So we can square this number. Oh, I hate it. And let's see what we get. Okay, 3.76 squared is 14.14, we'll call it. Okay, so I could leave it like that, but let's go back for a second. Didn't I already know what r squared was? Remember we had r squared was 10 square root of 2? That's really what I needed for the equation. So I could also just leave this as 10 square root of 2 and not even find r. 10 square root of 2. Does that make sense? Okay, so back here when we found r squared, that was enough. That's really what we needed for our equation, so we could have stopped there. But either way, I wanted to show you both ways. So either way is fine. Okay, question? All right. Now, next one. I am giving you a circle, and we're going to write the equation. So what two things do we need to know about this circle? What? The center point. Where is it centered? And what's the second thing? We need to know the radius. So, I mean, it's literally a matter of counting and figuring it out. Okay, so where is the center? And this is where I really wish I had my younger eyes. Does that look like the center there? Okay, so that ordered pair is -1, 2, 3, 4, -1. Y'all tell me if you're getting the same thing. Everybody good with that? And then once you figure out the center, then you're just going to count only one direction. Maybe check it by counting another direction. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I think that looks good. And so now we can write the equation. I'll write this at the top. Again, the formula. X minus h squared plus y minus k squared equals r squared. Okay, so here's our h, here's our k, here's our r. Plug it all in. X plus 4 squared plus y plus 1 squared equals 25. Any questions? Okay, next one. Oh, this one's easier, isn't it? Identify your center point. One, -6. Y'all tell me if you're getting something different. And the radius looks like just 2. So then I can write the equation x minus 1 squared plus y plus 6 squared equals 4. Would someone like to go check on him? Okay, thank you. Just make sure he's okay. All right, oh, we got to dig back in that brain. What's our midpoint formula? If you have two ordered pairs and you want to find the point halfway between them, that's the midpoint. What is the formula for that? So to have a midpoint, you have to have, maybe this will help you, two ordered pairs. You have to have an x1, y1, and x2, y2. How do you find the one in the middle? But remember, any guesses, if you're wrong, it's okay, we'll fix it. You are going to need to hold that thought, because I'm going to need that in a minute for distance. Yes? Okay, you're kind of on the same line as John. I think we're going to need that when we get to the distance formula, or you might also be thinking of slope formula, because if we do a fraction, then that's slope formula. Okay, if I find the middle of something, let's say you had 2 test grades, and you wanted the average. Are we okay? Oh, you want to get, does someone want to gather his things for him? Okay, thank you. Does he need anything? Like, does he need the nurse? Okay. So if you had 2 test grades and you averaged them, that average really represents the grade that's in the middle, doesn't it? So if you have 2 numbers and you average, it's finding the one in the middle. That's exactly what we do to find the midpoint. So we average the x's, which means we divide, add them up, divide by 2, and then we average the y's. Add them up, divide by 2, and that ordered pair will be our midpoint. Okay, so pretty simple. You want what's in the middle, so you just average. Okay, distance formula. There's a big square root. John said x2 minus x1. Do you remember what we have to do with that, though? Squared plus y2 minus y1 squared, which is really just a Pythagorean theorem rearranged there. And if you're not sure what I mean by that, look back at this equation right here. If I said solve that for r, you would square root both sides. So we just have a square root over this for r. That is basically this. Okay, so it's just a form of Pythagorean theorem there. Okay, so here's our distance, here's our midpoint. Why on earth are we talking about that? Because of the next example. Write the equation of the circle with this center and this point on the circle. So I'm not giving you the radius, am I? We're going to have to find the radius. Okay, now I know I didn't give you a graph to graph it, but just sort of sketch a rough sketch. If I plot -5, -6, which quadrant is that in? Third quadrant. I'm just going to plot it somewhere, like I'm not even really doing this accurately, but if I plot 2, 3, then that's somewhere up here, right? Okay, so this is the center. This is on the circle. That means that my circle is something like that. That's really bad, but just to give me a visual. Okay, well, what does this distance represent? The radius, exactly. So I'm going to have to use my distance formula between these 2 ordered pairs, but that distance will be the radius. So then I'll have the center and the radius. Okay, so these 2 ordered pairs are my x1, y1, x2, y2, and I'm going to apply the distance formula here. Okay? All right, you've been doing this a long time, so let's set it up. All right, here are my ordered pairs. x2 minus x1, but minus a -5 becomes plus y2 minus y1, okay? You just put your head down until they get here or go wait in the office? Here we go. All right, I hope you feel better. He's on his way. Okay. Are you dizzy, though?
I started shaking a bit. I'm not dizzy.
You're not dizzy. Okay, if you are, just sit down. Don't fall down, because you got a long way to fall. Hope you feel better. All right, so 3 minus negative 6 becomes 3 plus 6 squared. Okay, let's keep going. Y'all stop me if you have a question. 7 squared, 9 squared. Okay, so 7 squared is 49. 9 squared is 81. What is 49 plus 81? 130. That is not a perfect square, is it? If you're not sure if it can be simplified, these little yellow calculators are amazing and they will help us. Graphing calculators are no use when it comes to that. Doesn't even simplify. Okay, so we're going to leave it square root 130. And I don't really want a decimal for it because when I write the equation, remember we're going to square this quantity. So when I square the square root of 130, it will just become 130. Okay, so here's my equation. Remember, this is your center point. X plus 5 squared plus y plus 6 squared equals square root 130 squared. And then I would take it one step further. X plus 5 squared plus y plus 6 squared equals 130. Any questions on that? This one here? Here. Oh, those. Oh, you know what? I'm really glad you asked that. Okay, so I think this is what you're asking me. Why does this, don't even write this down. Don't attempt this at home. Why does that not equal 7 plus 9? Is that what you're wanting to do? Okay, so in other words, if I had x squared plus y squared, you'd want to tell me that that was x plus y. Okay, please don't write this down. Think about this. What if I had square root of 16 plus 9? And we applied this, and we said, okay, well, that's just 4, and that's 3, so that would be 7. But 16 plus 9 is 25, and the square root of 25 is 5. So which one is right? They can't both be right. This one. So when we have a sum, plus and minus mess a lot of things up. You know how when we were trying to cancel factors, if there was a plus or a minus, we couldn't do it? This is kind of another situation where if it's plus or minus under here, we can't just pick out each square root. It looks like we should be able to, but you can see right here with these simple numbers, it doesn't work. We don't get the same thing. So you have to add them first, then try to simplify. Now, if it's multiplied, rules change. If I had x squared times y squared, then yes, that's xy. Okay? So that is a really, really easy thing to do. So try to be aware of that, and I'm glad you brought that up. Okay, write the equation of a circle with diameter endpoints. 6, negative 3, negative 4, 9. Okay, I'm going to do another little rough sketch. It is not going to be accurate. I'm just getting an image of what's going on here. 6, negative 3 is somewhere down here in the 4th quadrant. Negative 4, 9 is somewhere up here in the 2nd quadrant. And that forms a diameter of my circle. Well, that means that the circle is something like that. So guess what? I don't know the center, nor do I know the radius. But I have enough information that I can find them. How do I find the center? Midpoint. The center is halfway between two diameter endpoints. Okay, so to find the center, I'm going to use the midpoint formula. So here's our formula. We're averaging x's, averaging y's. 6 plus negative 4 divided by 2. Negative 3 plus 9 divided by 2. Okay, so that gives me 2 over 2, comma, 6 over 2, which gives me 1, 3. Make sure I don't make a mistake. Okay, so now I know center point, which basically tells me H and K. But now I have to find the radius. Okay, so to find the radius, we have to do what we did up here and use our distance formula from center to a point on the circle. Well, here's our center. Which point do we use? Either one. Pick, if one looks easier than the other, pick it. I don't necessarily think one is easier than the other. What do y'all want to use? First one or second one? 6, -3. All right. So I'm going to find the radius by using distance of x2 minus x1. And if you use the other ordered pair, the other endpoint, you'll get the same radius, plus y2 minus, which becomes plus y1. Okay, let's keep going. That's a -5. That's a 6. That is 25 plus 36 is 61. That is certainly not a perfect square. And it doesn't even matter if it can be simplified, because what am I going to do with this radius? I'm going to square it, so it's just going to get rid of the square root. So let's just leave it, not even worry about it. Okay, so now I have my center point and my radius. I can finally write the equation x minus 1 squared plus y minus 3 squared equals square root 61 squared, which of course becomes x minus 1 squared, y minus 3 squared equals 61. Question? So far, so good? All right, last page. Oh my goodness, what is this? General form of the equation of a circle. Everything we've dealt with so far has been standard form. How is this different? What do you notice?
Dx, dy, f.
Yeah, there's a D and an E and an F. What the heck? What else is different? Equals 0. Doesn't equal an r squared. What else? What's missing other than the r squared? Okay. Huh? H and K. Where's H and K? And there's no parentheses. Okay, so can you guess how I'm going to go from standard form to general form? A 4-letter word. An F word. Foil. We're going to foil it out. So we're going to distribute, and that gets rid of all the parentheses, and then we'll eventually make it equal to 0. Okay, so general form. In all honesty, it's not very useful, because like y'all said, where's the radius? Where's H and K? By looking at a general form, I can't tell you where it's centered. I can't tell you what the radius is. I can't graph it unless it's in this standard form. This is the more useful form, but we deal with this sometimes, so we need to be able to go back and forth. Okay, so here we go. I'm going to get rid of parentheses. So that means x minus 3 times x minus 3. That's what x minus 3 squared means. Plus y plus 2 times y plus 2. That's what y plus 2 squared means. And then it equals 9. Okay, so we're going to distribute or foil, add up all the like terms, subtract 9, so that it's equal to 0. Okay, so here we go. X squared minus 3x plus 9 plus y squared plus 2y plus 4 equals 9. Okay, I'm going to add up like terms. Let's go ahead and do this. Watch this little fancy step here. I'm going to change this to minus 9 equals 0. See what I did there? I just brought that 9 over to the left. Okay, now let's add up like terms. And I'm going to add them up in the order that this equation is set up in. So I want to put my x squared first, then my y squared. Okay, so I have an x squared. I have a y squared. Okay, next I'm going to add up my x's, put them, let's see, I have, oh, those are it, negative 6x. Next I'm going to list the y's, that's 4y. And then plus f, that's just a constant, there's no variable with it, so let's add up all the numbers. I have 9 here, I have a minus 9, that's going to cancel, so I just have a plus 4 equals 0. That is my general form. Okay. All right, so I got ahead of myself with these directions. Ignore these directions here. They'll apply to the next one. So just sort of cover that up. It's not there. Can't see it. How would I rewrite this in standard form? Standard form is this one. So what would I have to do? One simple step. Why is this not like that? What would I have to do? Divide by 3. Divide by 3. Where's the center of this circle? 0, 0. See how it's just an x squared, not an x minus h? So that means, let's go ahead and divide by 3, and then I'll keep talking about that. Okay, I'm going to get rid of that 3. So that I have x squared plus y squared equals 192 divided by 3 is 64. Okay, that is in standard form. Now, if it helps, think of it as an x minus 0 squared and a y minus 0 squared equals 64. So the center is 0, 0. The radius would be 8. Okay, but all I had to do to that is just divide by the 3. Okay, much more involved here. This is where we have to complete the square. Do you remember that term, complete the square, from Algebra 2? Ooh, I see a bunch of no's. Okay, so there's a specific step-by-step way that we do this. I'm going from this form to this factored form. Okay? All right, so this is what I'm going to do. In a set of parentheses, put your x terms. So I have an x squared plus 6x. Leave some space for a number. Plus, in another set of parentheses, put your y's. Y squared plus 2y. Leave some space for a number. And I'm going to move that negative 6 over to the right. Okay, so I rearranged and I moved the constant over to the right. Because remember, in standard form, we want it equal to r squared. We do not want it equal to 0. All right, is everybody okay with that first step? All right, here's the funky part. Take this coefficient, 6, divide it by 2. That gives me 3. Square it. That gives me 9. I'm going to add 9 right there. Okay, but I can't just add something to the left side of an equation. I have to also add it to the right. Okay, there's a reason for all this that I'll explain in just a second. I'm going to do the same thing with this 2. I'm going to take the 2, I'm going to divide it by 2. Every time we divide it by 2, every time we take that number and we square it. Divide by 2 and square. Divide by 2 and square. That number gets added here. It's always added because when I square something, I always get a positive. So it's always going to be plus. But then don't forget, you have to add it to the right also. Okay, so what I have left is this thing that is a perfect square trinomial. Perfect square trinomial. Here and here. That take half and square and add is what creates a perfect square trinomial. Now, what is that? Okay, you know what a trinomial is. It has three terms. I have three terms here, I have three terms here. The perfect square part comes in like 16 is a perfect square, right? 4 is the square root. If a trinomial is a perfect square, it means that it can be factored into two identical factors. Okay, what are my two factors that will give me x squared plus 6x plus 9? To get x squared, I need x and I need x. What do I need to get a 9? 3 and 3, right? 3 times 3 gives me 9. Well, if all those are plus, these need to be plus. Do you see that those are the factors of that? Do you see that they're identical? So in the next step, I'll write it as x plus 3 squared. That's what a perfect square trinomial is. This can be factored into one factor that appears twice. And that crazy little step, take half and square, is what creates, it forces it to be a perfect square trinomial. Okay, so let's do the same with this. What are my factors? Well, I need y times y to get y squared. To get a 1, I need a 1 and a 1. To get a positive 2 in the middle, I need both of them to be plus. Same factor. If it doesn't factor into identical factors, you did something wrong, because that's what this whole little funky thing does. Create something that should have the same factors. Okay, now let's add this up. That's 10 minus 6 is 4. And then finally, the last step is to write x plus 3 squared and y plus 1 squared equals 4. And that is our standard form. So from that, I can tell you where it's centered at -3, -1, and I can tell you that the radius is 2. So much more useful form. Does that ring a bell now that you've seen it? Do you remember doing that in Algebra 2? Okay, some yeses. Any questions on that? Okay, let's do it on this last example here. So rewrite in standard form. I want it to look like this, that factored form, and it is all jumbled up. Okay, so my first step, let's just set it equal to, let's bring everything over. So I have x squared plus y squared plus 20x. Notice there are no y's. And if I subtract 4, then that will be plus 99 equals 0. Okay, so my next step, look what I did above, I'm going to group x's and group y's. So I have x squared plus 20x, leave some space. Do I have any y's to group? I just have a y squared. And then I don't want it equal to 0, so I'm going to move that 99 over. Okay, so I don't have to take half and square on the y's because I don't have a y term. But over here, I'm going to take that 20, divide it by 2, which is 10, square it, that gives me 100. So I'm going to add 100 here and also to the right to keep it equal. Okay, look at x squared plus 20x plus 100. What are my factors? $10 and x, right? So x plus 10 or minus 10, what do I need there? Pluses. Because I want to get a positive 20 when I FOIL or distribute it out. plus y squared equals 1. So what's the radius of this circle? 1. Square root of 1, which is still 1. Okay, so last step, then I'll get your question. X plus 10 squared plus y squared equals 1.
Registered for the PSAT. Report to the English hall for testing. Remember to go to your testing site.
For
with your
testing
materials
today?
and Chromebook.
That's like a
Bubble session or something?
like a technology test.
Oh, I think it's all online this year. Ooh, I forgot about that. Okay, anyone else? Okay, that was perfect timing, wasn't it? Let me get you your homework. Lanier, what's your question?
Are they always like this?
Lanier is full of good questions today. You would actually think that I gave him hints on what I wanted him to ask. I was waiting for someone to ask that, Lanier. Yes, look what happened here. This was a plus 3. What did we square? A positive 3. This was a plus 1. What did we square back here? A positive 1. This became plus 10. We squared a positive 10 back here. It's always going to follow that pattern. Okay? Question. All right, let me get your homework. All right, easy.